Okay, so good afternoon. This is the first module, week 1 and the lecture 1. So, this is in this particular lecture, we will start talking about what is plastic. As again, thank you for taking this course, and as you know, the name of the course is Plastic Waste Management. So, before we start getting into plastic waste, it is very essential to know what is plastic. Actually, what actually make of? Is it a organic chemical, inorganic chemical, or how it comes into existence? Little bit history behind plastic, how we started using them, and then we'll also in this particular week we'll also start looking at what is its usage, how much it is being used, both from a global context as well as in the Indian context. So, this first lecture, let's focus on what is plastic. So, we'll try to look at what is all this about. So, this is what we'll talk about, plastic, what it is, and then in the week towards later modules in the week we'll talk about types of plastic uses and global statistics. Types we'll talk about a little bit in this particular lecture as well. So, what is plastic? That is the most important when you say plastic waste management. So, we are talking about a waste which is essentially is plastic, or the major form of that major component in that particular waste is plastic. So, because when you hear plastic waste, it is not always 100% plastic, many times it would be 100%, but sometimes you will have plastic which is mixed with some other waste stream as well. So, plastics is essentially a synthetic material. It's as you know, it's an organic compound. As you may probably know, it's organic compound, very high molecular mass, and the reason why it is so much used is it's so easy to make different products out of plastic. As you can see in this particular picture, this is just is showing you the picture of a cutlery set, and in this cutlery set you can have plates, you can have spoons, you can have fork, you can have cups, glasses, trays, different types of glass, the thick plastic, thin plastic. So, this is just in a cutlery set you can see so much of variety in terms of the strength, and at the same time so much variety you can bring in terms of color and texture. And so, there are a lot of things that you can make out of plastic. That is the reason why it is very, very popular, and we will talk about how things are made as well. So, as I said, it's a synthetic or semi-synthetic organic compounds, very high molecular mass, and it can be molded into solid objects of numerous shapes and sizes, which you see pretty much every day. From the morning you get up, you hold the toothbrush in your hand, which is a plastic. You take your toothpaste from a tube, which is again a plastic, but it's a different types of plastic as compared to the toothbrush. And then you might be using certain plastic tap when you are trying to take the water out from those plastic tap, which is you using in your sink. That's again a plastic. The plumbing which is going down. So, just think about, I am just talking about just the daily morning routine of us taking our brush and that itself we are using different types of plastic, different shapes of plastic, from a toothbrush to the plastic tube for our toothpaste. Then you may have a plastic tap, which is sorry, not cap, but a tap for the water faucet. And then if you just look below your sink, you will have some like a caps, which will be some pipes, different type of like a plumbing, and then most of the plumbing these days in most of the buildings are of different types of plastics as well. So, that is why you see a variety of plastics coming up, and it's but essentially all those things that you see is a organic compound. Its main chain of that is an organic compound, which will have lot of molecular groups, which you may get mostly predominantly organic, but there will be certain blending of inorganic compounds as well. So, you will have some inorganic compounds which is added, and those are added to make give more strength to it, to make it more plasticized, like give it a more workable, so you can mold it in a different shapes and different sizes, and can give us a color, can use as a filler, and we will look into each one of those in terms of how they are used. So, as the reason why plastic is so popular is it is so handy. So, that is the reason why you see the different types of plastics coming up, different types of products coming up every time. Even nowadays you will have even many years now, you can buy the other day I was looking at some of those flower pots, which is essentially is a plastic, but from a distance if you look at it, almost looks like a earthen pot, because they give those textures, those nice patterns, but when you look at closer, when you feel it, it's actually essentially a plastic earthen, like a pot, which you can use for flowers and other things. So, and now for maybe last 10 years or so, we are also getting into bioplastic. That's why if you look at these two, the bullets, it says predominantly organic, mostly organic, because organic means I'm talking about non-biodegradable organic, and there are some biodegradable plastics which is also coming up, which we'll talk about later in this particular course when we got into alternative materials and all that. So, this is essentially just to give you a brief idea about what is the source of all these plastics. It's essentially organic. Now, if you look at the history, and as I mentioned in many of my courses in the class or online, wherever I'm delivering a course, for any course it's always a good idea to look at a bit of history behind it. So, what is the history, how it came into existence? And similarly, plastic, like since we are talking about plastic waste, essentially we are looking at plastic which has been discarded. So, plastic which was made and then it got discarded. So, it's always today if there is a kind of, I would say, gradually we also are getting a negative stigma being attached to the plastic, but plastic is so convenient and it has helped us in numerous ways to make a variety of products. So, that is why the person who invented plastic needs a lot of credit for doing that, but at the same time we could not manage the plastic waste properly. That is the reason why we are getting too much of hues and cries and plastic bans and global initiative on plastics happening right now. In fact, National Geographic, which you probably watch on TV, National Geographic channel, they are trying to do some work in India on plastic waste, and I am part of that particular team, which will try to do some work, and as we make some progress there, I will keep you updated as part of this particular course. So, in terms of history, it was the first kind of, you can say, the first compound which was similar to a plastic was done in 1862 in London, England, and it was a semi-synthetic plastic. It was done by Alexander Parkes in 1862 International Exhibition in London. So, that he call it parquet sign, which was an organic material, essentially cellulose nitrate and a solvent. That is what he used. And why the people were excited about that particular compound? Because it could be heated, it could be formed while it retained its shape. So, you can form it into different type of like a shapes, and when cooled it was molded product. You can make buttons, combs, picture frames, knife handles. So, people follow, okay, this material can be used in variety of ways. So, that was the first time, 1862. So, you think about that, today we are in 2018. So, 3218. So, almost 100 and how much, like 38, sorry, 38 and then 118. So, we are looking at 156 years ago. That is when this particular compound first came into, was reported to be in like public domain, where people started thinking about, oh, we can make a particular material like that. So, that was long ago, 160 some years ago, and now but the recent form of plastic is what we know is mostly synthetic plastic. What you saw earlier just before here is, as you can see, it is a cellulose nitrate. So, cellulose nitrate is essentially mostly you can say like a natural material, you can call that as well, but synthetic material which we use mostly in our traditional plastic today was discovered in 1907. So, that was what 1862. So, 1862, so another 38 plus 7, so 45 years later. And the reason why this material came into being, because people saw the benefit of having that kind of material which can be used in a variety of ways, as you can see the plastic being used today. So, synthetic plastic, Dr. Baekeland, he was a Belgian born chemist, sorry. He took phenol and formaldehyde, which you have taken some chemistry, so you know what they are. If not, just Google it, you will find phenol group and the formaldehyde. They are basic organic chemistry stuff that we all have learned in the schools. So, he took those two compounds and put it under pressure using hexamethyl tetraamine. So, hexamethylene tetraamine, so as a catalyst, and if you, I am pretty sure you know what a catalyst is. Catalyst is something which helps in enhancing the reaction. So, he used as a catalyst for the reaction under pressure, and the result was a thermostatic phenolic plastic, and he named it Bakelite, and which was electrically resistant, chemically stable, heat resistance, rigid, moisture and weather resistance. And if you think about, these are the properties which most of the plastic we use today also have, depending on what type, because we use it. The reason why, again, we use lots of different types of plastics, and the reason why we use all those different types of plastics is because they are useful. They are useful for the purpose for which it is designed, whether it is a plumber pipe, whether it is an electrical conduit, whether it is electrical wires which has a plastic liner on a plastic tubing, kind of a small plastic covering on whether it is an aluminum oil or a copper oil. So, those helps, and that is the reason why it is used. So, he made a thermosetting phenolic plastic first, and today we do not make it exactly the way he did, but that was kind of the first principle, and from there, as you will see in next as we make progress today, that there are different types, different ways we make those plastics. So, in general, and again this is a general process, and you may have very specific process from different plants, but this is which will have a modification of this particular process that you see over there, but in general this is what the process is followed, and this is what we are looking at in terms of plastic. So, here what we do, we have a monomer. As you can see at the bottom, we have like ethylene is used, which is ethylene under heat, pressure and catalyst, we make it a polyethylene. So, we have a ethylene which is CH2, and then we make a polymer out of that. So, as this sketch is trying to tell you, you have your monomers, which is put under heat, pressure and catalyst and converted to a polymer, and that polymer is used as a plastic material. But that is not only things that is happening there. You have certain additives, as you can see in that rectangle on the top. What are the additives? We could have some fillers, and we will talk about each one of them in next few slides. You will have fillers, you have plasticizers, you have stabilizers, you have colorants, you have lubricants, you have flame retardants. So, those things are added. Not all of them are added, but few of them will be added as needed for that particular type of plastic, as you will see in the examples. And then that is the additive that is added. But what is the process? Process, as I said earlier, it is essentially you are converting a monomer to a polymer, and that polymer is that since you are converting monomer to polymer, the process is called polymerization. And and you can do some condensation, or you can do some other addition of like a different types of compounds in there as well to give it a blended plastics, and those things does happen. So, which if you look at your remote, that plastic is actually not a traditional those number 1, 2, 3, 4, 7 that you see, but they are it's not a PET, HDPE or LDPE. It's actually not all of them, but depends. It's a mixture of different types of plastics together. So, that is why it is we make things from a different plastic compounds. So, that is essentially the plastic process. And so, now look at each one of those that we talked about in terms of additives. catalysts are used. Why it is used? These compounds are added to accelerate the hardening of resins, because we want to make it harder, so it will get the strength faster. They are used for quick and complete polymerization, so it helps in completion of polymerization. There are, for example, you can have Naegler-Natta catalyst is used in the synthesis of many alkaline chain polymers. So that's what you use for that. So that's for catalysts to make the reaction go faster. That's essentially what the catalysts do. Then fillers are essentially inert material, but why do we use them? Because it makes this, and our plastic gives strength to it, gives hardness to it, and some other properties can be enhanced as well. So, and it's used as a fibrous, laminated or power fillers. So, you put it in there, and usually what we use for filler includes calcium carbonate, talc, silica, clay, calcium sulfate, some calcium sulfate fibers, mica, glass beads are also used, alumina trihydrate is used. So, again depends on what kind of things you are looking for, you can have different types of fillers are added. But the reason why fillers are added is because to impart strength, hardness and other properties. If you are wondering that why I am going into these details, and in terms of because you have taken a plastic waste management course, you have not taken a plastic course, but we are talking about plastic waste management. So, we have to really understand plastic first, isn't it? We don't have, we are not going into is a chemical engineering, we will not go into detail of each one of those terms, but at least you should be aware of what are the different materials, because when you are looking at plastic waste will also have traces of calcium carbonate, will have traces of silica, will have clay, will have calcium sulfate, may have glass beads, because these all are used in them. So, they are there. They are there in the plastic. So, when you think about a treatment system for plastic, you need to think about that it's not only that organic polymer which is there. There are a lot of things which goes into making of plastic products, and we have to deal with those things as well as part of our plastic treatment system. Then plasticizer, as the name suggests, a plasticizer will do what? It will make things more gives more plasticity. Isn't it? Plasticity, what plasticity, and it will impart softness to the plastic. So, why we need that? Because to have different shapes, to make plastic in a different shapes, whether in a like a roll or a thin sheets, or you have to make you have to mold it into different kind of complicated shapes. And if its plasticity is more, you can do that. If it's not plastic, if it's not, the plasticity is less, the property plasticity as the property of that particular material is less, you may not be able to do that. So, there are lots of plasticizers which are commonly used are camphor, triacetylene, tributyl phosphate and those kind of stuff. Then you have a stabilizer. A stabilizer basically it acts as a stability, because since the plastics will be exposed to certain things, it will be exposed to light, it will be exposed to oxygen, it will be exposed to different environmental conditions. And the reason people buy plastic stuff, especially because they are stable. Say if you have a plastic chair at home, it's not that during just one winter and if you have AC on and then it becomes too hot, then again you have AC on and you have too hot, it should not crumble. It should not just crumble and start falling apart. So, it has to take different temperatures, it can take different sunlight. It does discolor. Say if you have watched plastic chairs, for example, especially used in functions or by caterers or decorators and those kind of people, if it's used in sun quite a bit, it does get discolored. And that is because of the impact of the light, impact of oxygen, like oxygen and the weathering conditions we call in general. So, stabilizers, this is the polymer stabilizers, they help in prolonging the life of the polymer. So, if you do not have these stabilizers, you will get the wear and tear happening much quickly, and if that happens, the product will not be stable. If the product is not stable, it will not sell. So, the whole plastic economy will not really work very well as it works, because people buy plastic stuff because it has certain durability. So, similarly here you have the polymer stabilizers helps to do that. So, if you look at some examples, there are 2,4-di like a butyl phenyl phosphide is what is used as a stabilizer in polymerization. Again, don't worry about all these big names. It's I'm not going to ask you these names in your exam, which you will take. And for the just talking about the exam, as you know, this is a NPTEL course, like other NPTEL courses you may have taken in the past, or if you have, this is your first course that you are taking. Each LPTEL course, we have an exam at the end of the course, which you should take, in my view, if you are taking this course, and to get credit for that course. There is an assignment part. If you are not aware of all this, go to our website on NPTEL, the course website. The details are there, because the assessment is done as a combination of both quizzes as well as exam. And the quizzes, every week there will be a quiz, and there will be an exam at the end, so which will be at a designated center, very similar to the GATE exam actually, that's how it is conducted as well. So if you are not familiar with that, most of you will be, because you may have taken other NPTEL course. Just in case if you are not, go to the website, all the details are there. In case you have any question related to the course or otherwise as well, put it on the discussion forum, and our team of we have a team which are helping run this course, so some of us will respond back to you depending on what kind of questions you have. So you will get the answer, so don't worry about that. So and usually you will get the answers within 24 hours. That's the goal we have. So coming back to the course, so it's a stabilizer. So stabilizer is used to basically give a longer lifetime, so things can stay for a longer period of time. Then we have colorants. Color, as you can see, there are it's essentially dyes and pigments. And why we need those dyes and pigments? Because that's why you see those beautiful colors, different plates, different spoons, different colored utensils, different colored of toothbrushes as well. And so you have variety of colors in plastic products, and those that comes because we use colorants. As the name suggests, colorants to help in color. So they act as filler, they impart desired color to the plastic. So addition of dyes and pigments, they helps in two ways. They act as a filler as well as they impact desired color. The commonly used pigments are zinc oxide, barytes, and etc. So those are used in terms of in color. Then you have lubricants. Now, why you will need lubricants as well? You might be thinking that plastic is already plastic. Like plastic means what? If from the soil mechanics, we used to call plastics plasticity index. So that means it is it's easily can be molded and all that. So lubricants helps in terms when we apply it to the surface of the mold, because when you are producing plastic products, we don't want the plastic to stick to the surface of the mold in which we are producing. Say if you are making a glass or we are making a tube, plastic pipe. So when it will be in a mold, as you have done, if you those of you who have done some sort of workshop practice as part of your engineering, if you are an engineering student or if you are even a diploma holder, you may have done some sort of workshop practice where we use variety of mold to make either even in your school you may have done clay modeling, where you have made like candles and other things in there as well. So we use mold, and the lubricants are applied to the surface of the mold. So the articles of plastic do not stick to the mold. So it lubricants on the surface of molds allows easy removal of the plastic from the mold as well. And the common lubricants that we use is graphite, paraffin, wax, etc. So those are the use stuff in there. Then this is very interesting, flame retardants, which is another additive is used. Now flame retardants, if you have followed the environmental news or environmental articles or looking at the risk, environmental risk from flame retardants, environmental and human health risk. Almost a decade ago, this was a hot topic, like we have PFOA and PFAS right now. So like flame retardants was was a hot topic, I would say in around 2004, 2005. A lot of research was going on in terms of the flame retardants. What are the different types of flame retardants? Mostly they are brominated flame retardants. You see a lot of bromine containing compound. It's an organohalogen compound. So they are brominated flame retardants, and they have certain adverse environmental impact. So this flame retardants, they're added during the process. Why it is added? To remove the fire propagating radicals. So you don't want fire to happen. Say think just a simple example, even if you just your laptop or you these days in your computer you use a lot of plastic. So, think about your laptop, you if you have one, or if you have been closer to a computer desktop, you see that they get heated up after a certain point of working, certain time of working, it gets heated up, and it gets heated up. You do not want that heat to get into some sort like a fire and then destroy your laptop. So, sometimes the heat is pretty, it gets really pretty hot, especially if your fan has some problem as well. So, in that scenarios, this brominated flame retardants, what does that mean? Flame retardant. So, it will not let flame to propagate. So, it will not like fire. So, it basically acts as a fire resistance or fire protection. You can probably, in a layman term, we can even say that. So, these are so to remove the fire propagating radicals, commonly used are brominated flame retardants, BFRs, and other organohalogen compound. Then we have solvents. These compounds these components are added to dissolve the plasticizers. So, we are use it as a solvent. It will help in getting things into solution. For example, alcohol is added into cellulose nitrate plastic to dissolve in camphor. So, those things are used as well. Now, there are different types of manufacturing is done with plastic. So, we will just talk about it a little bit in this particular module, and then we will continue this discussion in the next module. So, in terms of manufacturing with plastic, so far what you saw is what is plastic, what are the different, like what is the, it is essentially an organic compound, and which is a polymer. So, you take a monomer, you do certain reaction, you make it a polymer, you add certain additives, you add certain things to add strength, add color, and you get variety of different types of plastics made. So, now we are talking about the raw material plastic. Now, this next step would be to make product out of that. So, the raw material is good, but at the same time we need to make, say, PET, HDPE, those are just having like a long sheets of PET or long kind of PET compound in whatever form it is not going to help. We have to make different products out of that. So, there are different ways of making those products. We will talk about it in a minute, and then we will stop, and then we will continue in the next video. So, it's we can do manufacturing in a variety of way. You can do extrusion, you can do calendaring, film blowing, injection molding, blow molding, and bead blowing, rotational molding, compression molding, casting, thermoforming. And if you look at all these different terminology, they are not new. This is nothing specific for plastic. Same thing you may have seen it for glass. Those of you who are familiar with the glass industry, or for the matter any other industry as well. So, it all depends, it is a same process which have been using in the manufacturing world for quite some time. Once the plastic came in, we had to modify some of this process, but we have been using it. We have been using extrusion, calendaring, film blowing, and all that for quite some time. So, that's we will continue this discussion in the next module. So, this is like a first week lecture 1, and we talked about what is plastic. We try to, in the goal of this particular video was to try to introduce you to what is plastic, give you some idea about the background in terms of the history, like how this came into existence, and what are the different material kind of goes into making these different types of plastics. So, as you saw, there are plasticizers, there are colorants, there are flame retardants, there are dyes, and all those things that goes in there. So, when you look at plastic waste, plastic is there, which is the monomer, the polymer which was made from monomer, but at the same time lot of other compounds are also present. So, you should have that in mind when you start looking at solution for plastic waste. Thank you, and see you again.